Okay, here's a new problem. Now, how does this problem compare with the ones we've been looking at? Right, let's refresh our memory. All of these other problems had the instructions to simplify. Now, you're not being asked to simplify, you're being asked to factor. Now, if I ask you to simplify this expression, there's nothing to do. We don't have like terms, and I'm not dividing by anything. Right? This expression is already simplified. It's a trinomial, polynomial, degree 6, leading coefficient 5. Right? There's nothing to do here. But if I want you to factor it, that's something else. For this 4-term polynomial, it's already simplified by itself if we ignore the denominator. I can factor it, but this red numerator is not more simplified than the black numerator. We don't want to have parentheses in our answer. But if I want to unsimplify, perhaps so I could do some other operation with it, perhaps so I could then divide it by something else, who knows why I need to. We're not given a reason for why we want to factor right now. We're just given the command, factor this thing. So, to factor. The first thing we want to look for is GCF. Right? We talked about that in an earlier video. So if I look at these terms, this is 5 times a bunch of x's. I could write that out here, 5 times 6 x's. 5 is a prime number. Here I have 10, that's 5 times 2. X squared, that's 2 x's. 8, that's not prime, that's 2 times 2 times 2. X times x. And then I can look at these and see what factor do they have in common. Well, here's a 5, here's a 5, no 5. Here's some 2's, here's a 2, no 2's. Here's a bunch of x's, here's a couple x's, here's one x. X, 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 I can factor that out. So I can say x is the greatest common factor. Over here I'm left with a 5 and 5 x's. Here I'm left with a 5 and a 2, that's 10 and an x. Plus here. Here I'm left with 3 2's, 4 times 2 is 8, with the minus out front. And that entire expression is equivalent to this entire expression. Right? If I distribute the x to these 3 terms, I get the expression I started with. So this is my answer. Right? Not just the trinomial, not just x, but the whole expression. Let's look at another one here. Okay, this looks pretty similar. 5x to the 6th, 10x squared. 8x is now 100x. So I saw that they had an x in common. But now 5, 10, 100. One way to deal with these common factor factoring problems is to completely get the prime factorization of each term and look for what they have in common. That works, but just like with reducing fractions, it can be a little tedious if we already can see what the common factor is. Right? I know these all have an x in common. I also recognize that's 5 times 2, that's 5 times 20. They also have a 5x in common. So here I have 5x times a bunch more x's. One fewer x than the total I had before, right? Because x times 5 more gave me 6. 10, that's 5 times 2. 5 times 2 is 10, times x times a second x to get x squared. 100, that's 5 times 20, and I already have an x, so I'm done, right? I'm writing that 5x times whatever was missing from before it. And that makes it easy to just put that 5x out front, or technically we could put it to the right. We tend to put the monomial in front of the parentheses for this kind of factoring, but it could just as correctly have said this. Sorry, that's correct as well, that's right. But here I've got 5x times x to the fifth. Here I've got 5x times 2x with a plus, right? Double check, plus, plus. Here I have a 5x with a minus and the 20, so minus 20. And I'm good. Let's try one more here. This is looking pretty similar. 5, 10, and 120, those have a 5 in common. X cubed, x squared, plain x, those all have a single x in common. So I'll put that 5x, come on now, put that 5x there. And as we get good about this, we can actually skip this blue step and this intermediate step and just kind of do it in our head, right? So 5x cubed, that's 5x times 2 more x's. 10, that's 5 times 2 times x times a second x to get x squared. Minus is minus. 120, that's 5 times, let's see, 5 times 20 is 100. Let's just do this off to the side here. It ends in a 0, so I know it's divisible by 5. 5 goes into 12 2 times. 5 goes into 24 times. All right, so 24. 24 times 5 is 120, times x is 120x, negative, negative. Good. Now, trust me, I know 120 is 5 times 24, but I'm trying to think through the reasoning process that you are likely to go through. Okay. And so I've got all this, so now I get half credit. Because this is true, but it is not fully factored. How do I know that? Well, because I wrote the problem. But how would you know that? You have to keep on going. Right? When we look at these steps to factor a polynomial, they're not mutually exclusive. Right? Factoring out the GCF is a great first step because it makes the remaining polynomial easier to recognize as one of these. Here we go. For these first two examples, looking at this polynomial, 5th degree, that's not working into FOIL the way we usually see it. It's certainly not going to be a perfect square, so we can't really do much with that. But here I have a 2nd degree, 1st degree, constant term. I can do more. Now the question is this a perfect square trinomial? X squared, that could be, let me switch colors to make this clear here. X squared, x times x is x squared. Right? If I multiply this binomial times this binomial, FOIL would be x times x is x squared. Great. Is 24 a perfect square? No. All right. So it's certainly not going to be difference of squares because I have 3 terms, not just 2, even though this is minus. But it's not a perfect square. Question is, what can you multiply to get 24? Well, 24 is 6 times 4. Keep on going here. So we've got a bunch of 2's and 3's here. So I can do 2 times 12. I could put the 3 by itself. 3 times the other 2's, 3 times 8. put the two 2's together, and then the 3's with the 2. That's what I had 4 and 6. So that's it. Right? Well, I could also just do the silly way 1 and 24. Right? So I've got all of these factor pairs. I could say 24 is 1 times 24, 2 times 12, 3 times 8, or 4 times 6. And if this did factor into a binomial times a binomial, first x times x would be x squared. My outer times, my product of my outers and my product of my inners, those are both going to be x terms, so that sum will be 2x. And then the last, these two terms, will multiply to get 24, negative 24. So I could start with 1 and 24 and then see if that works, right? X times x is x squared. X times 24 is 24x. Well, now hang on. To get minus, if that's a plus 24, that's going to be a minus 1. Minus 1 times x is minus x, and the negative 1 times 24. All right, so this first term checks out. This last term checks out. The two middle terms here, 24 minus 1 is 23. Nowhere even close. I want a number that's actually pretty small. These two terms are moving in opposite directions. One's going to be positive because it's positive 24. The other's going to be negative because that's going to be negative here, right? To get a negative product, it's got to be opposite signs for these two. So going in opposite directions but close together so that they're only 2 apart. So 24 and 1 was actually a rather foolish first check. So let's try something else. Let's try the 5x there. 4 and 6, those are close together. So x times x is x squared. X times 6, because it's negative, is negative. 4 times x, positive 4. 4 times 6, as expected, right? So x squared, that's what we want. Negative 24, that's what we want. We just have to check this outer inner. So negative 6 plus 4, that's negative 2. But I want a positive 2. Those are not the same. So this is not my final answer. I want this to be positive 2. Well, how do I make that positive? Instead of doing 4 minus 6, I have to do 6 minus 4. So the 6 has to be a positive. The 4 has to be a negative. Let's double check that. Negative 4x, positive 6x, 6 minus 4 is positive 2. Positive 2, that's what we want. So my final answer, when asked to factor this expression, my final answer is 5x. I can't forget that common factor. The GCF is still part of my expression. And this trinomial factors further. X minus 4, or you don't want a plus negative in your final answer, and x plus 6. And ideally, your handwriting will show all of these kind of at the same level. Now, I know we need a lot more practice with this process, but my goal for right now is just recognizing, always look for that GCF first. I don't want to try to be doing reverse FOIL with a 5x cubed and 120. 120, negative 120, has a lot of potential factor pairs. Right? You thought 24 had a lot with 4 choices. 120's got a lot more than that. But by factoring out the 5, I made all of these numbers smaller. X squared is the easiest one of all because it's just x and x. Right? There's no other way to get x squared other than 1 times x squared, but then it won't be symmetrical. We won't get our FOIL working out nicely. Right? So factor out the GCF first, and then look to see what you can do from there. I'll walk you through some more examples in our next video.